any blank worksheet, just click on Minitab, it will open the worksheet. Okay. Now we'll go for one sample t-test first, or let's start with two sample t-test. Okay, one sample t-test हमने कर लिया है. Okay, चलो one sample से कर लेते. One sample t-test से कर लेते. Okay. Let me know once you are ready. Ready? Open. Very good. Very good. Very good. Chalo. So go to stat. Go to basic statistics. Open one sample t-test. Stat basic statistics one sample t-test. Okay. हम लोग just करके देखेंगे. We just do it. This window will open. Go to summarize data. Go to summarize data. No. Yeah, go to stat. Go to stat, basic statistics, one sample t-test. Done? Open that. Okay. So click on summarize data over here. Now there are 4 factors you need to enter here. Just listen to me very carefully. Okay. Now the 4 factors are basically the T statistics calculation. You can just make a note of this. X bar minus mu divided by S square root of N. Now what is T statistics? This is calculated T, which is critical T value. Critical T value is equal to T. Okay. X bar is equal to sample mean. Mu is equal to standard mean. S is equal to sample standard deviation. And N is equal to number of data points or sample size, you can say. Okay, it's sample size. Write this down. So I'll give you the data. Everybody make a note of this. No data, I'm just giving. I'm just randomly giving you the data. So sample mean, we will consider sample mean as 10. Standard deviation, standard mean is equal to, which is standard is 11. And sample standard deviation, let's consider to be 2. And number of data points, let's consider to be 16. Okay. So which means we have taken 16 samples and we have taken the average of each and every sample, and the average is coming to be 10. Are you clear with this? 16 samples we have taken, average of the sample. So we have added all the 16 samples divided by 16 is equal to 10. Okay. And the standard deviation for all those 16 samples is 2. Standard deviation is 2. And we are comparing this with the standard. So this mean, the sample mean is 10 and the standard mean is 11. That is why mu is equal to 11. Everybody's clear? And we have taken 16 samples. That's why N is equal to 16. Can you calculate the T value for me? Chalo, fatapat calculate karo manually. Pull out your calcs and calculate this manually, guys. Pull out this and calculate this manually. T statistics is standard mean is the standard. See what is we are talking about one sample T test. One sample T test. What is one sample T test? whenever we are comparing the average of one sample with the standard. Average of a sample with the standard. So this is the standard mean, which is 11. The sample mean is 10. Okay, type in the chat box, everybody. Done? Yes, Girijesh ji, fantastic. Everybody got -2, is it? NS, आपका शायद calculation थोड़ा सा गलत है, so I will do the calculation here. So x bar is equal to 10, minus mu is equal to 11, divided by standard deviation is equal to 2, divided by square root of 16. So square root of 16 is 4, right? So is equal to -1 divided by 2. So is equal to -1 divided by 0.5 is equal to -2. -2 होना चाहिए. Super, super. -2. Correct. Now let me just go to, let me just open. Okay. Now let me just open the statistical tables for the t value. Okay. Look at this. Now this is a t distribution table. I'll explain you this. So my n is equal to 16. So my degree of freedom is equal to how much? My degree of freedom is 15, n minus 1. So 16 minus 1 is equal to 15. Okay. So 15 is, so this is my degree of freedom column. So here you can see degree of freedom, the first column. So you can see 15 here. Okay, let me just enlarge it if I can do this. Yeah. Yes, so this is 15 degree of freedom. And what is my t value, which is -2. So -2 is nothing but you can consider as 2 only. So you can see here, this one is 2 and this one is 1.7, right? So this is between 2 and 1.7. So what is my p value? You can scroll it up and check the two-tailed test, 5%. So it is very close to. See, this is between, no, this is between this. Okay, let me just use my pen here. So this is my degree of freedom, which is n minus 1, which is 16 minus 1, 15. So 15, I'm coming here on this row of 15. And my t value is equal to -2. I can consider 2 only. So this is very close to 2, right? Because on this side it is 2.6, 2.9. So it is going greater than this. And on this side it is 1. So my t value is between this two. Okay. But very close to this. Okay. And if I see up, which is 5%, and in fact on this side, can you see here? So this is between 5%, which is 0.05, or 10%, which is 0.1. But this is very close to 0.05, but it is greater than 0.05. How many of you got it? It is greater than 0.05. How many of you got it? Because it is between these two. Just type yes in the chat box. So that means, so my p value is greater than 0.05. So you remember p low, null go, right? Null go. In this case, the p value is greater than 0.05. So we cannot reject null hypothesis. In this case, we cannot reject null hypothesis. Okay. Yeah, degree of freedom, I will explain you. Yes, samajh lo pehle, I will explain you degree of freedom. In this case, what is null hypothesis? Understand this. So now try to understand this. We have taken 16 samples and we have taken the average of all the 16 samples. And average is coming to be 10. Are you clear with this? Are you clear with this? Just type yes in the chat box. Okay. So this is sample average. Now, what is the standard average? Standard average is equal to, or this is also called as mu, is equal to 11. Correct? What was our null hypothesis? Null hypothesis says my sample average is equal to my mu, and my alternate hypothesis says my sample average is not equal to my mu. Now, see, understand this. There is a mathematical difference between these two. 10 and 11, there is a mathematical difference of 1, right? But because we are checking about a population, we are inferring about a population. With 16 sample data, we are inferring about the future. We are inferring about the population, the probability. Are you understanding? So we want to check what is the probability of this difference is statistically significant. Okay. So our p-value we have calculated, which is greater than 0.05, greater than 0.05. So as our rhyming is p low null go, right? But p is not low, so we cannot reject. So we accept null hypothesis. Null. What is null? Null is this. Okay. Null says my standard and my sample mean, there is no statistical significant difference. Are you clear with this? Just type yes in the chat box. Now the same thing we will do it with the help of Minitab. Are you clear? Now this is actually what Minitab does, at the back end. Okay. Now listen to me very carefully. Here we do not have exact value of p because now understand this. We have 10% ka data, we have 5% ka data, but nothing in between. We don't have 6% data, we don't have 7% data, we don't have 8% data, we don't have 9% data. But software Minitab has got all those data tables. Are you clear? That's why software calculates precisely the value and we will get just approximate value. Are you clear with this? Okay. अभी software से करके देखते हैं. Let's do it with software. Open your open your Minitab software. Now we'll do it the same thing with the help of software. Okay. Now, what is the sample size? 16. Everybody with me? What is the sample mean? 10. What is the standard deviation? What was that? 2, right? Standard deviation was 2. And we will perform the hypothesis test. And what is the hypothesized mean, which is mu? Type in the chat box, everybody. What is the hypothesized mean here? 11. Everybody with me? Just type yes in the chat box. So again, I will just quickly repeat. Sample size is n. Sample mean is x bar. Standard deviation is s. And hypothesized mean.
Shabash. Wow, sure.
Clear, everybody? Just type yes in the chat box. All right. Now let's click on OK and see what we have got. Look at this. Now let me just quickly reduce this and look at this. Just now understand this entire thing. Okay. What is this? First of all, take a second. Okay. So n is equal to 16, number of data points. Yes. Now I'm just reading all these tables. Here you can see here mu is equal to 11, mu is not equal to 11. Null and alternate hypothesis they have written. Okay. N is equal to 16, number of data points. The sample mean is 10, x bar is 10, standard deviation is 2, s is 2. Standard error of mean, what is standard error of mean is s divided by square root of n, which is our denominator of t statistic. Okay. Then 95% confidence of CI, confidence interval. Okay. So if the mean is x bar, with 95% confidence, we are saying that the population mean will lie between 8.93 to 11.06. Okay. And here is the t value. Look at the t value, guys. Look at the t value. Minus 2.00, which we have calculated. Yes. Can you correlate with this? T value we have manually calculated. And from the p value, software has precisely calculated the p value. Can you see that? We just said p is greater than 0.05. We said it must be somewhere between 10%, which is 0.1, and 5%, which is 0.05. Okay. We said it is between 10% and 5%, but software exactly calculated the p value was 6.4% or 0.064. Are you clear? Just type yes in the chat box. Now, we never have to calculate this manually, guys. Okay. As a driver of the car, again, I'm giving the same analogy. As a driver of the car, while driving, we never have to open the engine, open the gearbox, etc. But at least we should understand from where this is coming. Are you clear? Just type yes in the chat box. Super clear with this simple example? Just type yes in the chat box. Did not understand how to check from the table. Okay, I'll show you how to check from the table. Fantastic. Now you haven't understood because I have not shared the table with you. Okay, चलो मैं पहले share करता हूँ table को. पहले table अब download कर लो. First we will download the table. Okay, let me check if I have the table with me. Yeah, just a second. First, I will share the table with you guys. Okay, that will give you. Yeah, so all the tables I'm sharing with you guys. Just download it first. And once you download it, open that table. Yeah, I'll show you everything. First, you download this table first. And then you open your table and then I will explain you again. Correct. Exactly. So the probability of making error is greater than 0.05. So we have to, so P high, null apply. So we have to accept null hypothesis. Correct? Download it. Table open kiya aapne. Just give me yes in the chat box. Yes, open the table. So I've given you statistical tables where cumulative normal distribution C and D, which is nothing but a Z distribution, then the T distribution, then the F distribution, and the chi-square distribution. There are 4 different tables have been given. Now try to understand this. Now look at this. This is the first distribution, which is called Z distribution table. Okay. So all these numbers are nothing but the area under curve. For example, look at this. Just try to understand the basics. Okay. Now this shaded area, this is calculated on this number. For example, let's look at this number. 0.5, meaning if I put a value over here, the shaded area will be 50%. So 0.5 meaning 50% area will be under the curve. Okay. And this 50% area is nothing but a p-value. Are you understanding? So these are the area under curve we are basically calculating from the table. So let me just. So this is for Z table. Now let's scroll down below the Z table. There is T table. See, what is the difference between Z table and T table? The difference is when your sample size is lower than 30. Understand this? Okay, when your sample size now when is your sample size lower than 30? Let's say your sample is very expensive. You cannot take more samples, or your sampling takes more time, more resources. It's very difficult to take the sample. Those cases with a lesser sample also you can, you have to do the testing. Now, there was a statistician whose nickname was Student. Okay, so who introduced one distribution called T distribution. Okay, so it is similar to the normal distribution like this. Okay, but a little flatter distribution. Are you understanding? It is a little flatter distribution than the normal distribution. So this is called T distribution, and this is called Z distribution with normal. So this is when the sample size N is less than 30. Less than 30, go for T distribution. If N is greater than or equal to 30, go for Z distribution. So if you increase the sample size of T distribution, it naturally takes the shape of Z distribution. Okay, so this calculation below this is done for the T distribution. Okay, just for your understanding. Now look at this. Now coming back to our calculation. So first, what is degree of freedom? Degree of freedom is a statistical concept where the formula is called as n minus 1. N minus 1. What is n minus 1? Just to explain this concept in a very simplistic manner. Let's say, there are, for example, the average. Okay, average of 3 sample is 10. Average of 3 sample is 10, or let's say addition. Let's not addition. Addition of 3 sample is equal to 10. The first sample. So now understand this. Now there are a lot of probabilities, right? So I can pick up number 1. Another person will pick up number 5. Now addition of 1 and 5, because we know the total addition of 3 data points is 10. So the third person does not get any kind of freedom. So he has to choose 4, because 1 plus 5 plus 4 is equal to 10. So for first 2, you have the freedom to choose, and that is called degree of freedom. And the third person does not get that freedom. That's why it is always said that, so there are 3 number of data points, right? So the degree of freedom is n minus 1. So the 2 people will get to the freedom of choice, and the 1 person will not get the freedom of choice. This is called a degree of freedom. Okay. Now, how do we basically use this degree of freedom? Now, this degree of freedom concept was propagated by a statistician. One of the important statistician in that was Frederick Bessel. Okay. Now, according to Frederick Bessel, now you need not to remember all these names, etc. Okay. This is just for your understanding I'm giving you. Now, just for our understanding, why this n minus 1 is used. Now, try to understand this. In the standard deviation formula, just for your understanding, okay, this where this degree of freedom, etc. are used. Standard deviation formula for population is equal to, this is the formula, summation of xi minus x bar raised to square divided by n, and standard deviation of the sample, okay, which is s, is equal to summation of xi minus x bar raised to square divided by n minus 1. Now, this is the difference between this. Now, why there is a difference? Try to understand this. Population is a huge data set and sample is a small data set. When the data set is small, the variability also will be smaller. Try to understand this. Are you understanding this? Just type yes in the chat box. If huge variation is there, if the sample size is huge, there will be extreme values in the population, right? If the population is huge, there will be extreme values in the population. Yes or no? Let's take the same example of SNG students. Okay. Right now, if I take the weight of the students, it will be, I'm just giving you example. The maximum weight can be 90 kg of the students right now present in the room, and the minimum weight could be maybe 50 kg. Now, but if I take the population of SNG students, 70,000 students, I can have a student of 150 kg and I can have student of 40 kg. Yes or no? So population always have the more variation. Yes or no? Everybody got this idea? Population always have the more variation. Yes or no? Than the sample. Are you getting yes or no? Just type yes or no in the chat box. इसमें कोई doubt है? No sir, sample always will have more. ऐसा कोई है? Right? Simple है. Population will always have, always, no doubt about it. Correct? So if you remember the sample and population, so we predict the population standard deviation with the help of sample standard deviation. Try to understand this. So what Frederick Bessel says, this is called Bessel's correction or degree of freedom. He says, now while standard deviation, he reduced that one data point. So he reduced the denominator so that the sample standard deviation will get a boost, will be a little enhanced. Are you understanding? Because the variation itself is low. Okay, just to boost that variability, he has reduced the denominator. If you reduce the denominator, obviously the total value will increase, right? This is the logic of Frederick Bessel. and introduction of Frederick Bessel's correction of this formula or degree of freedom. Anyway, this is the statistical concept. The simple formula is n minus 1. Okay, now coming back to how did we calculate this p value? Coming back to first we calculated the t value. Okay, first we calculated the t value. The formula was x bar minus mu divided by s over n square root of n. When we put all the value, we got minus 2.00. Okay, the t value was minus 2.00. Now, and n is equal to 16, correct? So, what is degree of freedom? df is equal to 16 minus 1 is equal to 15, right? So, here is degree of freedom. So, here is 15. From 15, we will go on this horizontal line and we'll find out this minus 2.0, but there is no minus value. So, we'll only check the positive value. So, here we can find out in this row, what is the nearest value you will find? You will find this is the nearest value. Yes. Okay. Now on this side, this is on the higher side, but our value is 2.0, right? So this is between these two values. Are you clear? Priyanka, are you clear with this? So our value must be between 1.75 and 2.13. Yes or no? Because it is 2.0. Correct? Now, so this is between this. So if I see above, it is 5% and 10%. So my t value must be between 0.1 and 0.05. In both these cases, it is greater than 0.05. So which software calculated exactly which is 0.064? Correct? So it was actually when it is 2.0, this value, the p value is 0.064. So which is greater than 0.05. So P low null go, so P is high, so null. So we cannot reject null hypothesis. Are you clear? This is how from the T table we calculate the P value. Got it? Fantastic, super. Now, for the what you can say, two sample T test, we have got a little different formula. Okay, what is two sample T test? Whenever we have got, let's say, two different samples, x bar A and x bar B. Okay, so the null hypothesis says x bar A is equal to x bar B. The alternate says x bar A is not equal to x bar B. Okay, so that is called two sample t-test. So the formula for everybody knows about this two sample test when we compare two samples with each other. It's called two sample t-test. Yes, everybody knows this, just like yes in the chat box. Or for the new people, whenever we compare one sample with standard, it is called one sample t-test. Whenever we compare two samples with each other, it's called two sample t-test. For example, two batsmen, Rishabh Pant and KL Rahul, I want to check whether there is a statistical significant difference between the averages of Rishabh Pant and KL Rahul. Or delivery time of the vendor. I will take delivery time of vendor 1 and delivery time of vendor 2, and I will check whether there is a statistical significant difference between two vendors. It is called two sample t-test. Okay. So there is a slight difference in the formula. You can just make a note of this. In that case, yeah, the t value is calculated as, write this down, xa bar minus xb bar divided by square root of okay, divided by, in the denominator, square root of standard deviation square, which is variance of A divided by NA, which is number of data points of A, and plus variance of B divided by number of data points of B. Are you clear? Just take this. This is for two sample t-test. This is a formula for two sample t-test. Okay. One sample t-test के लिए the earlier formula t is equal to x bar minus mu divided by this. This is for one sample t-test. Clear, guys? Just type yes in the chat box. So once you collect the data, you have to calculate. So only the three things are required. What are the three things? X bar, which is the mean of sample A, right? X bar B, which is the mean of sample B. Then what is this? Which is variance. You get variance or standard deviation, the same thing, right? If you take the square of variance, it is standard deviation. It is sample A ka variance and sample B ka variance. And then NA is equal to number of data points of A and number of data points of B. Now, for two sample t-test, you can have different number of data points. Huh? For example, in A sample, you have 20 data points. In B sample, you have 22 data points. It is also okay. Because ultimately, we are taking average of it. Are you understanding? We are taking average of it. That is the only thing. Clear? Just type yes in the chat box. So we have to calculate a t-value on the basis of degrees of freedom. We will go there and check the t critical and conclude about it. The same fundamental. Same fundamental. Clear, Prasad ji? Are you clear with this? So I can give you the example, but again, calculation में लोगों को 10 मिनट चला जाएगा. Sure? Fantastic. So let's calculate this two sample t-test. Open your Minitab software. I'll just close this. No, I'll just keep it as it is. Open your Minitab software again. Okay, we will do it with the help of Minitab now. Okay. Chalo, open the same data file. That is also okay. Open the same data set. It is also okay. So here I have got some weight data. Or you can just create. Okay, let's create the data set. Okay, go to calc, random data, normal. Just select this. Calc random data normal. We'll generate some data set and we will do two sample t-test. Okay. So calc random data normal. Now, number of rows we will generate. Let's say we will generate 20 data points. Store in the column C2. The mean, I would take the mean as 10 and standard deviation as 1. Okay. So mean as 10, standard deviation as 1. I'll generate a data set. So this data set has been generated. And in the column 3, C3 column, in the C3 column, instead of mean 10, I will generate mean 11. I will keep standard deviation as same. And I will say okay. Okay, so here, this is C2 column and this is C3 column. For C2 column, the X bar is equal to approximately 10. And here X bar is approximately 11. Number of data points are 20 each. So N is equal to 20. Standard deviation is equal to 1 for both. Clear, everybody? Now we want to compare, is there a statistical significant difference between sample 1 and sample 2? Are you clear with the data set? We have generated data set and this is how it is coming out to be. Clear? Let's do this two sample t-test. Do this two sample t-test. So I will go to stat, basic statistics, go to two sample t-test. Now here we will select each sample in its column because there are various columns we have, right? Each sample in its column. So sample 1, I'm selecting C2. In sample 2, I'm selecting C3. If you have C1 and C2, you can type C1 and C2. Okay. because I already had a data set in the C1 column. I have taken C2 and C3 and just say okay. Here, so from the value, this T value is calculated, which is found to be 0.74, and the P value is 4.64656, which means the P is equal to 0.465. So P low, null go, right? So, but the P value is not lower than 0.05. So we have to apply null hypothesis. We cannot reject null hypothesis. So there is no statistical significant difference between this, the mean, this and this. Okay, your value could be different because your software would have generated a different data set. Okay, so my values are different, so your values could be different. Clear hai everybody? This is how two sample t-test is done. Yeah, you got, yeah. So your sample will be different. So you got 0.009. So you have to reject null hypothesis, right? Fantastic. Are you getting this? Just type yes in the chat box. Super clear? Yeah, degree of freedom का formula ना थोड़ा सा यहाँ पे थोड़ा सा अलग है. Now this degree of freedom formula depends on variability, the variance basically. If there is small difference in the variance, understand this, the degree of freedom formula changes. I'll give you example. Okay, I'll show you a different example here. Let's look at this. I'll show you a different example. Let's go to two sample t-test and I'm going for summarized data. Okay. Now listen to me very carefully. Yeah? I am writing summarized data here. For sample 1, my sample size is 20. My sample mean is 10 and my standard deviation is 2. Okay. Here, my sample size is 20. My sample mean is 11 and my standard deviation is 2. Now I have taken exactly equal standard deviation. Understand this? Are you getting my point? Now, when I have exactly equal standard deviation, my degree of freedom formula is n1 plus n2 minus 2, which is nothing but n minus 1 ही है. Okay, so which is nothing but 20 minus 1 and 20 minus 1. So 20 minus 1 is equal to 19 and 19. So degree of freedom will be 38. Okay, when my standard deviation is exactly equal to each other, then my n minus 1 formula will be applicable. But if there is a difference in my standard deviation, so my degree of freedom formula will be a little complicated. Okay, now इसमें मैं करके दिखाता हूं आपको. So now I will calculate this, two sample t-test. I say okay. Now look at this. Look at this, my degree of freedom, guys. 38. Are you observing this? Just like yes in the chat box. My degree of freedom has changed because it is n minus 1. 20 minus 1 is equal to 19 and 20 minus 1 is equal to 19 because my standard deviation is exactly equal to each other. Standard deviation of 1 and standard deviation of 2 are exactly same, but in the sample I've taken, there is a difference in the standard deviation. So the formula of degree of freedom changes. That's the only difference. Clear? इसमें ज्यादा पढ़ने की जरूरत नहीं है. Let's stick to the topic. P value को देखो, P low, null go. That's it. And drive the car. Don't worry कि इंजन कैसे चल रहा है and gear box में क्या हो रहा है. ठीक है? This is, I've just taken you what happens at the back end in the software. So that, see, when you go to the black belt and the master black belt level, you should be able to explain all these characters here. All these characters. Clear hai everybody? Yes? Now can you correlate now with each other? Yeah, so if you want the formula थोड़ा complicated है, लिख लो. If you are, if the standard deviation, for example, X, this group A and group B, right? So we are comparing. So X A bar and X B bar we are comparing, right? So we are calculating variance as well. If variances are not equal, okay. So the degree of freedom, this formula, ये इसका formula क्या है? So degree of freedom for such cases, okay, for such cases when there are not equal. तो ये आप लिख लो, मुझे भी याद नहीं है, मैंने जस्ट मेरे इसमें है, इसलिए नोट्स में है, इसलिए आप लिख लो. So this will be in the denominator, in the numerator, whole raised to square divided by ये आप करके देखो if the time permits. This is n, n minus 1, na minus 1. Same goes to variance of B divided by NB square divided by. This is the degree of freedom for formula. Yes, we can calculate the t value from the table. हम लोग कैलकुलेट करेंगे, ये लिख लो पहले, हम लोग कैलकुलेट करेंगे. Done. Again, you need not to remember. Even I don't remember this formula. Okay, remember करने की जरूरत नहीं है, but just you should know why the degree of freedom is different, because the variances are different. That's the reason degree of freedom are different. Yeah, software will do. Software, we just put the data in and software will tell you the p value, right? So we need not to have the degree of freedom calculation and t value calculation. Go to the table. इतना time भी नहीं है. We don't have that much of time. We have to solve the problem. We are not here to become statisticians. Okay, done, guys? Done. चलो इसको एक बार कैलकुलेशन करके देखते हैं. So with this t value, which is minus 1.58, okay, let's calculate this. And degree of freedom 38. Let's see if our software, our table allows us to use this. Okay, so degree of freedom is 38. देखते हैं 38 है क्या? Yes, 38 है. And 1 point, what was that? 1.8 था ना, क्या था वो? 1.58. Okay, 1.58. Can you just calculate? Can you just find 1.58 there? 1.58. So 38 and 1.5. So 1.58 is even, इससे भी less है. Can you understand this? So this is 38. So this is my 38. And if I see here, my lowest value is 1.6. So my 1.58 will come here, somewhere here. Are you understanding? So if I scroll up, so my p value must be greater than 0.1. Yes, because it is greater than 10%, 0.1. HOD will terminate. Okay, so 0.1. So we will go back to our software. Software has calculated 0.122, which is 12.2%. Software has exactly calculated p value, which is 10.2%, which is 0.1122. Clear hai everybody? Just type yes in the chat box. This is what the senior people were curious about. Sir, how do we calculate a p value manually? One sample z test, one sample t test, two sample t test. So we have come here. Okay? Yeah, explain one and two tail. Now, what is one tail and two tail? Now, if now you want to check is my x bar A is greater than x bar B, greater than, or my x bar A is less than x bar B. So you just want to check one-sided. Is it greater than? It is called one-tail test. If you want to check, is there any statistical significant difference? That's it. It is called two-tail test. So it is like this. If it is statistical significant difference, it is software will calculate the area considering both this. Just like USL and LSL, no? So USL and LSL, right? So we can make defect in both the direction, right? On the lower side as well as in the upper side, correct? But if we have only unidirectional specification limit, let's say for example 30 minutes are free. So if my what I can say, my target is only unidirectional, 30 minutes. If anything less than 30 minutes is okay. So let's say this is 30 minutes, and anything goes beyond 30 minutes is a defect. So it is called one tail. It is called one tail test. Clear? There is a difference between one tail and two tail. Yeah, super. अच्छा, मैंने इसके ऊपर लिख दिया. ओके, मेरे यहाँ पे अलग है. ठीक है, चलो. अंडरस्टैंडिंग क्लियर हो गया.